Welcome to the first ever episode of Science Nights. I'm Josh.
I'm Adam.
I'm John.
And this is the first time we're ever going to try something like this, but we are going to endeavor to give you the best and brightest of science that we can get our hands on. So I guess first and foremost, you should get a look at our logo, which is very fucking
nice
beautiful.
fancy logo.
That's pretty.
Yeah, it's just right over John's left shoulder right there. So
Right here.
yeah, it's exactly right.
Okay,
And
can
Can I Vanna White it? All right.
Adam, I wonder, could you, before we get down into some science of the show, we got a couple things to go over, and one of those is where do you see the inception of this show coming from?
Where it coming from?
Yeah, why did we decide to do a science show?
Well, I feel like this show is very much a kind of a spin-off from Waiting for Players. We started talking so much technology, and that led into space, and
What's
we
space?
keep talking more and more about space. Space is everything. You're in space right now.
You're made of stardust.
Absolutely, we all are. Star stuff, by the way.
Oh, star stuff,
Yeah.
not dust?
No.
They're not dust.
Star stuff sounds way cooler.
It does.
So just, yeah, our love for science and space and...
Yeah, gadgetry, I think, is what got me into it. The idea of engineering and continuing to improve upon technology that's already there, whether
Nice.
that's confining it or making it stronger.
Well, and I think all of us just already enjoyed science, and then getting to talk about it so regularly every Monday, now we're like, let's talk more about it.
So then, if you had to pick like a favorite field of science, where would you?
I would have, man,
It's a tough one, right?
right? Because like,
Well, like
physics is insanely interesting, but so is chemistry to me, because the thought of like, mixing different chemicals.
Yeah.
I don't know. You just feel like a mad scientist.
Chemistry is mind blowing sometimes.
Right.
Chemistry is also pretty much the basis of most things. So, to really explain a lot of the fields of science, you have to be able to explain chemistry. So.
And math is the language of science.
Math is the language of the universe.
Yeah. I would say from
I'm
my
illiterate.
You're illiterate. I would say from my perspective, my favorite field of science is either biology or geology. Geology because you can figure out how old the world is, and biology because we're biological organisms.
Yeah.
Earth science in high school, I loved that class.
Yeah, the more you know about not only where you are on Earth and where your Earth has come from, but also like more about yourself, the more that you can understand the greater universe.
And what
Right.
shaped your Earth.
Yeah.
and-
Yeah.
And biology is definitely very interesting, especially when you get the cellular level and
Oh, for
how
sure.
how cells work and it's
how your
mind-blowing
behavior interacts on a minuscule, like a molecular biological level.
stuff. Like how it's influenced by
For sure. Like
absolutely.
not only how your behavior changes because of it, but how your behavior alters your molecular biology. For instance, I'm talking specifically about dehydration. If you choose not to drink water and only drink like certain other fluids like coffee or dehydrators like alcohol or Rockstar, your cells will actually contract, and that's that feeling you feel when you're just like, God, I'm either parched or I'm sick or something like that.
Right.
You get
That's
weak
your
and shaky too.
that's your cells going
See?
like,
Steady as a rock.
feed us, man. We need water. That's why water's so important,
Water is definitely vital.
But that also comes down to a chemical reaction.
I heard you're 12% water.
Adam, what's your favorite science?
So we won't always get the facts right on this show, but we will try to.
70%? 70% water, that's guess 2.
My favorite field has always been astronomy. So anything dealing with astronomy, space, absolutely. I have a space tattoo. I don't know how well you can see that. From,
Tattoo.
We'll
I guess
definitely-
it is
we'll
one
delve
big
more
one
into
It is
it.
now.
one big one, yeah.
Yeah.
It's,
As we
You
do
don't have
astronomy
that.
episodes, we'll sew a different part of Adam's tattoo is what we're gonna do.
yeah, I've always I used to sit outside when I was a kid and just watch meteor showers, and from Texas, so we had a lot less light pollution down there than we do up here.
Oh, I guess that's a good point. We're based out of Seattle, Washington.
Right. So our viewing's not that great. But that being said, I was up here in Seattle the first time I saw Saturn's rings and Jupiter's moons through a telescope.
And screw you guys, we got the Space Museum, we got the National Museum of Flight. So the space shuttle's here. The space shuttle's in our town.
Boop. I swore right there. You just couldn't hear it.
And like John pointed out, that we're all made of star stuff.
Star stuff.
Everything. Astronomy starts everything, basically.
So don't let anybody tell you you're not a star.
Everything.
Sometimes
was that motivational? Did you guys feel uplifted?
So another thing we should point out about Science Nights is we're encompassing the greater Lazy Night shows. We have 3 shows that we do. We have Comics Brew, Waiting for Players, and Bad Flicks. And among those 3 shows, there's 7 different hosts, Adam and I included, and John included. So the Science Nights part of this is not only because we're like errants against error and we safeguard the world from ignorance and and not understanding.
No, it's mostly just a play on the Lazy Nights.
Mostly just a Lazy Nights thing. So we'll have a rotating series of hosts. John's going to join us for these first couple, and then we're definitely going to have to.
They'll never have me back after that once they see the ratings.
Yeah, ratings. Yeah.
We got negative downloads this week. What?
They gave us data.
12 comments that say all because of John. My favorite quote involves space, actually.
Go for it.
Shoot for the moon. Even if you miss, you will land among the stars.
Not really, because between
space is really, really big. So most likely,
a lot of nothing out there.
Most likely, you'll just keep going straight forever and never hit anything.
Well, you land among them, not in them. You're not going to fly through the center of it.
Like Look, maybe like 5 billion years from now, you'll do an orbit around the Milky Way center of the galaxy, and then. No,
I'm going to hit a Lagrange point. Just chill.
There are also no stars between here and the moon, so if you shoot for the moon, you never end up under the stars. Unless you go like way past it, and then you're probably going to die.
It says shoot for the moon even if you miss. Miss would imply that you went past it.
You could miss if you fall short.
You could, but how would you stop in space?
Same way Superman does. Kryptonian brakes.
Kryptonian brakes. I feel like I should not have shared my favorite quote with you guys because you were just like, "That's a stupid quote."
How about this? To segue into someone that does have a favorite quote of mine. One of the big things, another driving reason for us making a science-based show is because of I wouldn't say lack, but just like we want to be science communicators, and one of the biggest science communicators that we can think of made a famous speech called The Pale Blue Dot, and that would be Mr. Carl Sagan. Dr. Carl Sagan, excuse me. He is by far and away one of the most important figures, not only in astronomy, but in the greater world of science. And right now I'm listening to his book, Pale Blue Dot. Mm-hmm. We heard his speech, Pale Blue Dot, before we started recording today.
Yeah, we listened to it again.
He's something of not only a genius, but something to aspire to, I think. Because not only is he a scientist in his own right, but he's able to communicate it in a way that sounds more than just like on a chalkboard in a classroom.
Yep.
So much work that he put into the Voyager 1 and Voyager 2 missions, which we've learned an amazing amount of data from, you know.
And he was the one who convinced NASA to turn Voyager 1 or 2, I don't remember which one or 2 around.
Turn around and take
a picture of our solar system.
The famous picture of the furthest picture ever taken of Earth at that point. So.
Yeah, that mote of dust.
Now, while Carl Sagan for us is definitely a very good basis, and we'll probably do an episode solely on Carl Sagan, another big science communicator for us and someone who's definitely shaped my early childhood was Mr. Bill Nye.
This science guy.
This science guy made classroom science applicable to people that had televisions. Like his show on PBS was amazing.
Absolutely.
And I can still remember some of the experiments or demonstrations he gave. Like the one that sticks out for me is he went down to the Kingdom and put the sun in the moon of the sun in the center on the pitcher's mound, and then showed the phases of the moon around by going around the diamond on the different bases.
There's a visual representation of how
Of the
that
phases
works.
of the moon. Yeah,
Mine
exactly.
was his little hovercraft he made, and then like
Of science!
It's actually honestly the only episode I remember from my childhood, but I watched a lot more than that.
The water cycles, I remember, because every time they had a music video at the end of every one of their episodes, and I remember the water cycle music video. It went from evaporation to condensation to
I did watch a fair amount of Bill Nye when I was younger too, but I've seen a lot of his newer stuff. I've listened to him on podcasts. And,
Star Talk.
Star Talk Radio.
Currently,
he's doing other interviews and.
Well, right now he's out there pushing against like the creationists and stuff, talking about evolution, trying to keep creationism out of the schools. He doesn't think it's right, as well as climate change.
Climate change.
He's been a big advocate going out there talking
about
climate change and just saying, hey, this isn't like a Chinese hoax. Like we have stuff to support this. It's not just like conjecture.
He's also pretty big on the whole GMO scene for people against GMOs, and he gets a little flack from that because he did change his opinion on it at one point. Like he was strongly against them, but then he learned a bit more about it and he changed his opinion on it. So a lot of people are like, oh, he got paid by Monsanto to change his opinion. When realistically, I mean, like we'll get into, like the whole scientific method revolves around you might not be right. Like, there may be something that disproves something later on, and that's what science is all about is learning.
Absolutely. Another big science communicator that we have to talk about, and I think everyone knows and loves the man, is Neil deGrasse Tyson.
Carl Sagan was his mentor, right?
Yeah.
Yep.
Yeah. The first episode of the redoing of Cosmos, at the end of it, Dr. Tyson talks about his relationship with Carl Sagan.
Right.
But if you want someone to not only have the voice of Morgan Freeman, but also the scientific knowledge of like near Stephen Hawking intelligence, then you want to look towards this guy. There's not a YouTube video out there that doesn't contain a little bit of Neil deGrasse Tyson as far as science goes. This guy, not only can he put you to sleep because his voice is amazing, but his knowledge is vast and it's amazing.
Yeah. I really enjoyed, because people really like to ask Neil deGrasse Tyson, like, well, if you don't believe in the Bible and God, and like, what happens to you when you die? And then they're like, what do you want to happen when you die? And he was like, I would like to be buried back in the earth so the flora and the fauna can feed off of me as I fed off of them. And like, and I was just like, clap, clap, clap.
Yeah. Good man.
Right.
You tell it like it is.
He's also a doctor too. I don't know if you said that.
Yeah, Dr. Tyson.
Yeah.
Yeah, he's an astrophysicist.
Yeah.
And that's another thing. These three men were all scientists in their own right before they became science communicators. Bill Nye, I don't think he has a doctorate.
He's an engineer.
He's an engineer.
He worked on...
which is still science.
He worked on the 747. He worked on the space shuttle. He was a big engineer at Boeing. Carl Sagan, obviously, a doctor and professor. And Neil deGrasse Tyson, a doctor as well. These men are the idea of geniuses. And while none of us are going to be scientists yet, we are definitely influenced by them, and we want to thank them for everything that they've done as far as communicating the importance of science in the world. Now then, so we want to be communicators. We want to do that. We want to spread the good word about science. But we also there's another ulterior motive to this, and that's just learning in general. We want to learn more. There's no reason not to, and we want to bring you along with it.
Hopefully, everybody learns something.
Exactly.
By the end of all of this,
increasing our brain power is exactly what we want.
If you guys have questions, we can answer them.
We'll try.
Like I said a little bit earlier, we will try our best to get everything right. We're not professionals or experts ourselves. We're just science enthusiasts.
Enthusiasts, it's a good word. Yeah, I like that.
I'm Dr. John, like Dr. Phil's a doctor.
Now, it's not just about learning or that we want to communicate things. There's some things about science that are fun, and you just have to wrap your head around the fact that it's still science. One of the biggest things that I've discovered fun lately, and it's all science, is cooking. I've had a great time. We're doing this in the summer of 2017 for their first one, so I've had a great time this summer cooking, and there's nothing like grilling steaks, man. What you have to realize about grilling steaks, though, is you're changing the chemical composition of something as you're adding heat. The heat's the catalyst for the chemical reaction. Well, I mean, Adam, what would you say happens to a slab of steak as it goes onto the grill?
Well, you're starting to break down. You're starting to melt the fat, and you're breaking down a lot of the enzymes in the meat. You're also caramelizing the outside of it, so that's what's giving you the char. But cooking, like, temperatures and times change a lot of things in cooking. So if you're cooking like a big slab of meat too, the higher the temperature you get, that's when you get, like, you know, falling off the bone tender and stuff like that. Is because you've gotten to the point where you've rendered all of the fat inside the meat.
Mm-hmm.
And
Can you render my fat?
I'd rather not, but
Yeah.
I mean, I guess.
It's probably not tasty either.
But seeing as that both me and Josh are pretty fond of cooking, I imagine there'll be more than a few cooking episodes in the future at some point.
I guess we should probably get this out of the way soon too. We're going to be doing short demonstration videos on our YouTube channel. That'll be Science Nights on YouTube. We've got a couple already planned and started shooting for the near future, but cooking will probably be one of them.
Oh, yeah.
As summer goes along, Adam tends to be like the master barbecuist, and I'm trying to see if he'll let me help document it, but if not, that's okay too. But yeah, like Adam said, we'll be definitely doing a cooking episode, at least one.
No, probably end up being a series, to be honest.
Yeah,
but-
exactly. Science Nights Cooks.
Well, we'll be doing lots of videos, so I mean,
sure.
Demonstrations, some experiments, probably some, like, I don't know, a bit of like explanation and stuff like that too.
Sure.
So.
You know, there's more about science that's fun too. John, you'll know more about this than I do right now, but in the dating world, a lot happens with biology as you meet attractors and different forces out there.
Pheromones.
Hormones.
I mean, at its core, right, biology is about sex and survival.
Mm-hmm.
So, I mean, that's a big part of the dating world, right, John?
I've never had sex, so I couldn't tell you specifically.
But you're still here, so you've survived.
I've survived it, yes.
Survive not having it?
Have had some near misses.
Some close calls there.
But it is crazy, the chemical reactions inside the body when you're attracted to somebody and what the brain decides.
And it's not just that either. It's the psychology of it too.
Yep.
I mean, and even if I disagree that it's a hard science, there's some sociology involved in modern courtship and dating.
But there's also there really is like a chemistry between people.
Oh, for sure.
I
I turned most
She
people into
was
salt.
beautiful and funny and sweet, but zero attraction. Like, we made out, and I was just like, that's the first time in my life I've felt nothing. Like, you know, and it's a thing.
Am I a serial killer now?
No, but it is. It's extremely interesting what goes on there. I couldn't explain it to you because I've never done it. I mean,
And you know, of course, we can't mention the fun parts of science without talking about NASA's space program and any space exploration in general.
So I'm not seeing the picture you have up right now because John's slow on the mouse, but the violent reactions and physics-defying applications.
Oh yeah.
No, I like that because we definitely will be talking about not only just the simple enough, rockets to get us to the moon, but
the idea of fighting against the outside of the vacuum of space that is there to kill you essentially.
cosmic radiation, all that kind of stuff, absolutely, and also the bending of the fabric of space-time.
Absolutely.
I didn't know
and
it was
then
made out of fabric.
You know,
well,
what else is
you will be learning? So.
What else is there to benefit from, or what else is fun about science is volcanoes, man. We live in Washington. We live in Washington State, where Mount St. Helens erupted some 30 years ago, and if you go to the mountain today, you see how that affected the entire geology around the area, and the flora and fauna have actually flourished because of the additional carbon in the soil.
Yeah.
But right now, what you're seeing if you're watching us on YouTube, you're seeing an underwater volcano.
Which are always the coolest ones to watch.
Because they're
right?
the hottest.
And just the way the lava bubbles out of the... Yeah.
I actually just always, when I see lava and water, I just always enjoyed the thought that lava will never win in water. It just won't. The ocean's too vast. There's too much of it, and the lava, no matter how hot it is, just can't compete with that much. So, like, when you were watching lava, like, pour into the ocean and there's steam going crazy, it's just like, no matter how hard you try.
It's going to cool off the surface.
Exactly. And
it's not going to boil the ocean away.
Exactly.
So,
And it's just like, no matter how hard you try lava, water beats fire in this scenario. Like, there's no chance. I also think the mega volcano in Yellowstone is insanely
Old Faithful?
Not Old Faithful. That's a geyser.
No, but the mega volcano there. If that ever went off, there goes the entire West Coast.
Pretty much, yeah.
All of it's gone.
Right.
It's a terrifying thing to think about. And then, like, when you watch a video and they're explaining, like, how the surveys are showing the land is actually, like, building up higher and higher, I'm just like, that's a time bomb I don't want to be around for. Like, you know, but at the same time, it's insanely, like, I watched a documentary specifically on it, and it was just mind-blowing. You're just like, wow, we're not only us are screwed, but, like, you know, they're talking about, like, rocks from it when it erupts, like, landing in different countries.
Oh, yeah.
Like,
Just the ash plume would cover the whole Earth. Like, it would have, we would lose, it may take out half the country, but it would definitely affect the entire planet.
Yeah,
for sure.
So, I mean, shit,
and there's been eruptions like that in the past.
When that volcano went off in Iceland a couple years ago, that affected the flight plans of every country around around Iceland for a while. I know there's not much; it's a lot of water, but still.
Because they've got, like, rocks, like, that don't belong on the continent, like, in a rock wall, and the only explanation is a volcano launched it. Like, and when you think about that, you're just like, oh, hell no. Like,
I mean, it can, yeah. Volcanoes are interesting, right? Because that's showing you, like, the inner workings of our planet.
We also live by a giant one.
Also, you know, volcanoes are just the Earth's pimples. They're just waiting to...
But there's there's volcanoes all over the solar system. You were talking about, like, rocks getting launched out. Some volcanoes on some of our moons and stuff in our solar system will launch things into orbit around them because their gravity is not so high.
That'd be weird.
And then
my moon gave birth to a smaller, tinier moon.
I mean, not only the geology of our volcanoes, that gives us hints into how mountainous ranges appear on, like, Mars, where, what is that, Olympus is in
Olympus Mons is the largest volcano in the solar system.
Yeah.
And it's dormant right now, but they believe that in about 50 million years or so it could actually become active again. So
geology's wild. And the last thing that I think is mind-blowing about science, and the thing that's awesome, is the insane amount of power that exists on the infinitesimally small part of the world. Atoms and atoms and the energy that they give off when they shed neutrons and shed electrons is ridiculous. And the fact that we, like, the United States devastated Japan just by splitting an atom in a bomb.
Think of all the good we could have done with that power instead.
Right?
We still can do good with that power.
Yeah, we can, but everybody's scared of it now.
Of course, because that's the first demonstration we had of it.
Right, exactly, was the devastating power of it, you know.
I think it's crazy that where they tested them out in the desert, the heat, you know, is so intense, there's these big freaking sheets of glass from the sand melting, which I've always wanted to go see.
Yeah, but... the reason, so that's like the threefold reason for us doing this show. We want to be science communicators and spread the good word of the science, and we want to highlight some of the coolest parts of science, and we want to learn ourselves. And that's maybe we'll talk about the ethics of science in the future. We probably should.
We probably will. I mean, we probably will at some point. Like you're saying, the biggest point of this, or one of the biggest points at least, is just that we enjoy science and we want to talk about it.
Yeah, exactly.
So.
Exactly.
And hopefully you enjoy it too.
All of that being well, maybe, I don't know. All of that being out of the way, let's get some definitions out of the way too. There are several words about science that need to be clearly defined before we can continue. And the first and foremost of those is a theory. Yes. A scientific theory is definitely vastly different than what most people throw around as a theory. Like, I have a theory.
Right. I have a theory because I just thought of something.
Yeah, I just thought of something real quick.
You know.
I actually heard somebody saying that same thing last night, talking about the Big Bang theory.
The show?
And then no. And he's talking about, and then, like, he clearly had zero understanding of what the Big Bang theory was. And he was talking... It was killing me. But basically, you know, he's like, it's just a theory. There's nothing to back it up. Blah 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 blah.
That's
I'm
not
like,
true.
That's not true.
Absolutely
You know,
not.
he's like, it's just a theory. Like somebody, like you said, thought it up, spit it out there, and then bam, all the scientists were like, yeah, sounds good, right on, I'm on board.
It's just like the whole theory that Pluto's not a planet. Like Jerry says, you can disagree with science. It's just an opinion. No.
No, you can't.
So here's the clinical definition of a scientific theory. It's an explanation of some aspect of the natural world that can, in accordance with the scientific method, be repeatedly tested using a predefined protocol of observations and experiments. So what that means is this has been tested enough and has been repeatable enough that we can actually infer that this is close to how this works. It's important to note that the definition of scientific theory is ambiguous, but it's very much... I guess not the definition is ambiguous, but the usage of the word theory is so ambiguous that you sometimes get confused with it.
Yeah.
Right.
But what are you going to say?
For the most part, when we say theory here, we're meaning the scientific theory, the full definition of it.
So those theories are the theory of relativity, the Big Bang theory. Those kind of theories are what we're talking about.
Right. Those are all theories that have been proven mathematically time and time again. A theory could almost be called like a
absolute,
a proven
almost
hypothesis.
There
right?
you
like
go.
A graduated hypothesis. So you start off with your hypothesis, and then after you've had it proven multiple times and by other people, peer reviewed. Then you can start calling it a theory. And anytime a theory is ever disproven, it's failed and it's not a theory anymore.
Yep.
So it can't be false.
There's also a law. A scientific law exists. What it does is it explains the reactions of things in very specific environments or conditions. It has nothing to do, like, the Big Bang Theory encapsulates a lot of stuff, but, like,
A law has
Newton's
no
law,
bender, right?
Newton's third law of motion or whatever, is only about this one specific thing.
Right. Yeah. Laws are very specific in their what they're telling it to do, right? Mm-hmm. So a good example of that is like because a law doesn't describe how it works, just that it does work. So evolution, like evolution is a law, and the fact that we can see evolution happening, right? We know for sure that evolution happens. The theory of evolution is describing how it happens.
Yeah.
A law doesn't have to describe how it works. It just, so a law and a theory go hand in hand. They're not like how I said, theory is a proven hypothesis. It's not like a graduation from there, you know.
Gotcha.
So from there, from law and theory, we can start to talk about the scientific method because we've mentioned that already. The scientific method, think of it as like the recipe of science, and how this is the repeatable process for testing some part of the natural world.
I'm going to break your flow because I wanted to say one more thing about theories.
Oh, sorry, go ahead.
Too far away. That's fine. A theory can change also, right?
Oh, for sure.
It just because it can't be disproven, but it can evolve, right?
Yeah.
So like a good example of that is Newtonian's or Newton's theory of gravity evolved into then special relativity and general relativity.
After Einstein got there.
Right.
Yeah.
But it's still, Newton's laws still work. Newton's theory of gravity still works perfectly. And as long as it's within you're not talking huge scales or really high gravity, high bending of space-time, then most of the time NASA still uses Newton's formulas to figure out where to send spacecraft.
Which is pretty amazing.
And you see how they get that shit on the dot.
Yeah, well, they've got to.
There's
There's no wiggle room in what they're doing, which is why it's always so crazy to see.
Yeah.
Like the James Webb Telescope, like that's going to be, like they can't be off by anything.
Yeah.
Like they have to hit their Lagrange point and everything right on the
Exactly.
money.
Oh,
They
yeah.
have no wiggle
Yep.
room. Like, and that's why I'm illiterate in the language of science.
That's all.
That's all math. Yeah, exactly. It's all math, and it's
I
all
would be
so
like-
complex that a modern calculator, like a
couldn't
modern
hit
phone
the
calculator,
sun.
can't do it. You have to have like
Scientific calculator.
calculators.
If I tried
yeah.
to launch something off the Earth and hit the sun, I couldn't hit the sun. Like that's how bad I'm at math.
Yeah.
I couldn't.
I
It's
couldn't
very-
either.
wouldn't be able- yeah. Like,
Dude, you know how hard it is to hit the sun? You got to be going really, really, really fast. Or
Shit, I
just-
hit Mercury.
Or you'll just orbit around it.
So I want to get into the scientific method, and like I said, it's like this the science recipe. It's how you design an experiment, how you make that experiment repeatable, and how you ensure that the conclusion is actually legitimate. So first, the scientific method is you develop an experiment or a hypothesis. A hypothesis is an educated guess that precludes or predicts the outcome of a given experiment and highlights the testable variables. So normally this is in a very simple, this can be simplified as an if-then clause. So what I have on the screen and what I'm going to read is, if I punch John in the face with my fist, then I can expect a reaction of equal or greater force from John. So that's what I'm going to be testing, is me punching John in the face. And the reaction I get from him is what I'm looking for at the end of this experiment. So from there, that's where we've started. So then we highlight a procedure. We set down a series of steps that are intended to make this procedure repeatable. John, you're going to get punched a lot. I'm sorry.
Not only would it have to be repeatable, but with your controls, you would have to be hitting with the exact same amount of force in the exact same location. But then you'd also have to allow for wear down on my face. Like, you punch me in the same spot 3 times in a row, then you probably
break something.
Yeah.
Or my hand.
This is going to take months to
you're going to have to let me fully heal, rest up.
And then there will be a control, like John said. We're going to
I feel like there's too many variables in this experiment.
Not only are we testing John's reaction, but we're also going to test John's reaction in a controlled sense, meaning we're going to test not punching him in the face and see if that has anything to do with it.
What if I still punch you in the face?
That's resentment. That's another outside variable.
That's an outcome that we have to take into consideration.
Yeah. That's what we call outliers in science. But the best way to describe a control is, have you ever heard of the placebo effect? So let's say a company is testing a new pain medication on a series of testers. They have a group A and a group B. Group A gets the new medication. Group B gets the sugar pill, the fake medication. The sugar pill is the control. That's what they're using to compare their new medication. So a control is a method of comparison, and it's usually something that's already heavily defined.
And often a double blind, right?
Mm-hmm.
So nobody knows.
So there's no way to influence it either way.
Yeah.
It's a good point. John's double blind thing. It's a way to get rid of bias, because that's another problem with humans.
So double blind just means, right, that the person that is giving the test doesn't know it either.
Yeah.
So.
Yep, and they're just administering it. Everything looks the same.
And then finally, after you've conducted your experiment, you have a conclusion. I'm basically describing what I learned in math or in biology at school. Like this scientific method.
Yeah.
Your conclusion, it summarizes your results, and it also, you confirm or deny your hypothesis, and you can move forward. You can look at further study if needed, or test another variable.
I think that's one of the favorite things, is when you're writing the conclusion and things didn't come out exactly how you expected to be, or doesn't match your hypothesis right off the bat.
Right.
And then you have to amend your hypothesis and then try again.
What you think is going to happen based on the results.
On what you've learned, and then you can refine your experiment.
That's the beauty of the scientific method. One other thing on here, too, that's part of this conclusion of analyzing the data is now you want this to be peer-reviewed.
Yeah.
Right? So, obviously, if you're conducting a huge experiment that matters, you'll get, published in a scientific journal and stuff. But
I was going to say, I think one of the fun things about science, though, and the scientific method is when you are wrong, it's one of the few things where I think you can be wrong
and
still be genuinely excited. Be okay, that didn't react how I thought it was going to react.
Absolutely.
And then threw me a complete curveball. So now I've got to come back and try to figure out why that curveball did what it did.
And that can range from your hypothesis is off, or there's something in your procedure.
Right? Maybe you have too many variables.
That's why you want someone else to test it, to see if they can find. So in your example now, I have to punch John in the face.
Yes.
To try to find out if there was either something wrong with your testing, or if the results match up.
Exactly.
So everything you just went through, then I'll have to do it again now. So
we'll do that in 2018.
Another couple months.
Yeah. It'll be good. It'll be good times for John. For you audio listeners, he's just shaking his head. He's not liking it.
The whole time I'm going to be like, for science! And hospital bills.
So that was a very, very truncated version of the scientific method. And before we get out of here, there's 2 more things I want to talk about. One of those things being the difference between correlating evidence and causation, or cause and effect. So a correlation is just 2 variables that seem to coincide or have a mutual relationship or a connection. One of those things might be, it's hot outside and I'm thirsty. I get thirstier as it gets warmer. That's
Right,
a
right.
correlation. Now that might also be cause and effect, but you can't determine that unless you test it.
Absolutely, right.
That's the problem a lot of people have with correlating data. Like, oh, that's the cause. That's exactly what's going on. That's the cause. No, that's just correlation.
Yeah. But you can set up an experiment and determine cause and effect
Yeah. Now
by following the scientific
you'll
method.
hear a lot more of this probably through sociological areas. Like cause and effect is thrown around a little bit more there, like specifically socioeconomic instances where they say poverty leads to crime.
Me back.
No.
That's not cause and effect?
Well, that might be cause and effect.
We're done with that example, though, so.
You guys like virtually beat the shit out of me, and now
Over the next 2 years.
and then I make it like my one comment. and
We're
then-
done. Moving on.
Yeah, John, let it go. Let it go.
But it's like the difference is like these might be related, but there's a direct effect after this happens. That's what
Right.
cause and effect is. And like I said, there will be socioeconomics is probably where you hear it the most, where correlating data is used as causation, and that's not necessarily how that's supposed to go.
Right. Well, that seems like that could almost be like just jumping to conclusions.
Sure,
right?
exactly.
So you're just making assumptions off of something that you not always, but
Now, before we leave, we want to invite peer review in these. We want if we get something wrong, but something you liked, something you saw that we did, or that you want us to do or talk about, please let us know. But peer review is probably the biggest part. We want to be as accurate as possible, and we invite criticism.
yeah. So don't feel,
Except trolling.
yeah. Well, this is the internet.
Yeah,
so
exactly.
trolling's gonna
Right.
happen.
I guess bring it.
Also, if you enjoyed watching an experiment, you could do it yourself, videotape
Oh yeah,
it, and then
and show us your results.
show us your results.
Sometimes we might disclaimer that you might not want to try this at home, but
You know, if we do-
Oh,
like
yeah.
a blanket statement, hey, go try everything we do, and then let us know what the results
He's gonna catch
are.
a bullet in his teeth in the second
So-
episode.
But we don't want you to try that at home.
Well,
I
no.
might. I'd like to see videos of it too.
So I don't know. Maybe we should take that one as we go. But
Well, I mean,
but
there's
yeah.
a lot of stuff you could do at home
Oh,
without
yeah.
killing
Oh,
yourself.
most likely.
Maybe use some common
Most
sense.
likely.
And if you get the disclaimer, don't try this at home.
Don't try it at home.
Yeah, there you go.
That's pretty
There you go.
explicit. Like, don't.
But no, definitely we want feedback. If we, he's like Josh said, we take criticism well. If we said something wrong or got something wrong, please correct us.
We'll even
Correct
apologize.
us, with the right answer. And not,
Yeah, don't just be
I
like,
guess that
I
goes
don't.
with the
Pluto's a
trolling part.
planet.
Yeah.
I don't think so.
And definitely, if there's something, I mean, we're just starting out. We've got a few episodes planned out. But if there's something you would want us to hear about us talk about, or watch us do, or something like that, definitely let us know.
Absolutely. So I guess we should probably leave by teasing something.
Ooh, don't touch me,
We're not
John.
punching John in the face next episode.
I was just gonna tease him. We tease something.
How about this? We
Well-
have a regular correspondent at NASA, and
do.
we should be getting to talk with him in the near future.
So it won't always just be us that
Yeah.
don't really know what we're talking about.
Exactly.
Like, every
We'll
once
find
in
out
a
how
while-
incompetent NASA is. It's
Yeah,
gonna be great.
every once in a while we will have some people on here that
I heard
do
they
know
got
what they're
big
talking
brains
about.
over
We
there.
got them
NASA.
big old brains in the NASA's.
I got one. She.
And like we said earlier, we're going to be doing some demonstration videos, so be sure to check out our the rest of our YouTube page, because you can either listen to this audioly. We got a
Audioly?
audible. I don't know, audio or orally.
Orally. There we go.
Yeah,
Maybe? I don't know.
yeah.
don't know,
AURALLY.
Oh,
Orally.
So through your aura?
No, through your. I hate you guys.
Oh, I just poked myself in the eye.
I was going to say, that doesn't seem very scientific.
Or
but-
smart.
Orally, it's a word. I'll show you later. I'm gonna put a big old orally up on the video, and then we'll really get some views.
He's gonna show you orally
But
later.
what-
That's uncomfortable.
Either way, what we're getting at is you can listen to us or watch us.
Or watch us. Jeez. And
Visually.
Visually.
Whoa.
Ocularly.
Yeah, ocularly.
Occultly. Wait.
That's not very scientific either.
No, not at
Yeah, we should.
But thanks for joining us for this first episode, and we will see you guys next week.
Yep.
Bye.
For science.